Everyone, welcome to IB Methodology, your space for mastering IBDP mathematics. Today we are solving AAHL May 2025 paper 3 questions step by step using a clear and exam oriented approach. So let's start with the question. In this question it says consider the curve given to you as this. The first part says sketch the curve for minus 10 to 10 x values. So once you will insert this equation in your GDC, you can see this graph, and this is what you have to sketch for the first part. The main important point here to note is your graph should pass through 0, 0, that is the center. Now the second part of the question says state the coordinates of the points that crosses the x-axis. Crosses the x-axis means basically your x-intercepts. So for the second part, when you will use your GDC, when you will press G solve, you can see there is a term written as x-intercept. So when you will press that x-intercept, you will see three different points. The first one will be minus 4, 0. Second one is 0, 0. And the third one is 4, 0. If I mark these points as A, B, C, so this point is my A point, the black one is my B point, and this is my C point. So this is A, this is B, and this is C point. You can check in your graph as well. Now, the third part says state the coordinates of the local maximum point and the local minimum point. So for this also, again you have to use your GDC, and when you will press G solve, you will see max and min both. So when you will press max, you can see 2 points. One is your x coordinate, that is minus 1.94, and the other one is your y coordinate, that is 1.20. And when you will press min in your GDC, you can see one point as 1.94 and another one as minus 1.20. Now where you can see this in your graph? So the maxima point is basically this point. I can name this as D, and the minima point is this, that is E. So this is your maxima point and this is your minima point. Now the B part of the question says state whether this given function is odd, even, or neither, and we have to justify our answer. So before moving on to the solution, we have to first check how we will solve B part. Now, what is odd and even function? So let's say you have a function fx, and now in place of x, if you are putting minus x, so if I replace x with minus x, and if I am still getting my function back, it means it is an even function. And when I am replacing x with minus x, but I am getting minus fx as my answer, it means it is an odd function. Now in this also, instead of x, we will put minus x. So let's see, if I replace x with minus x, everywhere in the function, I will get this as my first step. If you solve it further, minus x square is x square minus 16 upon x square plus 16. Now if you look into this bracket, it is nothing but your fx. So from here you can clearly see that your fx is equals to minus fx. So it means it is an odd function. Let's move on to C part. For C part, you have a different function as this, where a is a positive constant. And you have the function fx as this. We have to prove that f dash root a is independent of a. So first of all, we have to find out the derivative, and then we will be replacing x with root a. So you can use quotient rule. So whenever you have a function fx, that you can, this formula you can see in your formula booklet also. So if I want to take its derivative, it will be vu dash minus uv dash upon v square. So let's write this function. It's x into x square minus a upon x square plus a. So I can write it like this also, just for the sake of simplicity. Now I will be applying quotient rule, this rule, into my function. So let's see how we will get its derivative. So it's vu dash. So v is this and u dash means d by dx of x cube minus ax minus u as it is d by dx of v dash whole divided by v square. Now if I take out the derivative, now here you have to note that a is a constant. So I can write it as it is. Derivative of x cube is 3x square. A is a constant. Derivative of x is 1. I can copy this as well. X square derivative is 2x. A derivative is 0. Divided by denominator will be the same. Now if I simplify this further, I can replace x with root a. So I can write it like this. Now everywhere I will replace x with root a in the derivative. 3 root a whole square minus a minus root a whole cube minus a into root a. Now it's basic simplification. Root a whole square plus a whole square. Root a square is a plus a becomes 2a. This is also a, so 3a minus a is again 2a minus root a cube is a root a minus again a root a bracket 2 root a whole divided by root a square is again a plus a is 2a. So now here if you will see, this term will become 0. So I can write it as 4a square upon 4a square. It means these two will get cancelled out and my f dash root a comes out to be 1. It means this is independent of root a. Now let's move on to D part. Next part, it says show that this term is equals to the RHS. So I will be starting with LHS only. So the simplest step is I can take x square plus a as my LCM. So I will be getting x bracket x square plus a minus 2ax. If I take x square plus a as my LCM, now I can simplify this and I can write it like this. So x square plus a. Now these two terms will be a cube minus ax divided by x square plus a. Now if you see here, this from this term I can take from the numerator, basically I can take x common and I can write it as x bracket x square minus a whole upon x square plus a, and it is nothing but your right hand side of the first part. So for doing this you will get 2 marks. Let's move on to the second part. Determine the equation of the oblique asymptote to the curve. So before determining the equation, let's first understand what is an oblique asymptote. So basically, it's whenever in your given function, if your degree of numerator is exactly 1 higher than the degree of denominator, in that case you have an oblique asymptote. So in the above function, you can see that you have x cube in the numerator and x square in the denominator. It means this function will definitely have an oblique asymptote. And the equation will be y is equals to x. Let's move on to the third part. Write down the coordinates of the point of the curve where oblique asymptote is parallel to the tangent of the curve. We got our oblique asymptote equation, this, and we have the equation of the curve as this. It means both must have same slope. So if you want to, let me write 3 here. So if you want to find slope of this, so your dy by dx for both should be equal. So slope of your oblique asymptote is 1, and when you will find its slope dy by dx, and when you will equate it, its slope will come out as 1 minus 2a bracket a minus x square whole divided by x square plus a whole square. Now we have to equate this and this slope. So when you will equate these two, you can put this in your GDC and you can see that your x square minus a will be equals to 0, which says that x is equals to plus minus root a. But the important point is they ask the coordinate, not the only the x coordinate. So your answer should be root a comma 0 and minus root a comma 0. For this, you will get the desired marks. Now in this part, it says for this differential equation, if we substitute this, we have to use partial fraction and show that this is the answer. So let's start. First of all, we have to use partial fraction. So we have to break it down. We can write this in the form b upon 1 plus v plus c upon 1 minus v. In the denominator, I have applied a square minus b square. Now, if I further want to simplify this, there are multiple methods to simplify this. If you take LCM, you will get this. And now, both sides, if I write, my denominator will be the same on both sides. So I can write b minus bv plus c plus cv. So my denominator will get cancelled and I can take b and c together. I can take v common and I can write it like this. Now 1 means we have, now we can equate, this 1 is a constant, we can equate constant with constant, and since there is no term of v in the RHS, it means we can equate this with 0. So when you will equate this as 0 and when you will solve these two equations, we will get b value as half and c value as half. Now once we got our b and c value, we can replace the values over here. So what we will be getting is integration b is half, so half upon 1 plus v dv plus again integration of half upon 1 minus v dv. Since half is a constant, so we can take it out from the integral and we can write our integral like this. Now integration of 1 upon 1 plus v, if you remember or see your formula booklet, you can see that it's ln modulus 1 plus v plus again half ln modulus 1 minus v. Don't forget to add the constant, that is ln a. Now you can write it as half ln a or ln a. It's your wish. You can write plus c also. All are fine. I can write this as ln modulus 1 plus v plus half ln modulus 1 minus v plus c also. So now when I apply the log properties, I can write it as half ln e to the power 2c into 1 plus v upon 1 minus v, where your e to the power 2c is equals to a. If you compare your this result with the given one, we can say that if I replace a with e to the power 2c, these two red boxes are exactly the same. Moving on to the next part, it says show that the solution to the original differential equation may be expressed in this form. So first I will write the form. It was x dv by dx is equals to 1 minus v square. So we can attempt to separate variables and integrate. So if I want to separate the variables, I can write dx over x is equals to dv over 1 minus v square. Now I can integrate both sides. I will get ln modulus x is equals to half ln a 1 plus v upon 1 minus v. This is the answer which I got in my last part, so I have written it as it is. Now we can attempt to use power rule of log. So when you will use power rule of logs, that will become ln modulus x is equals to ln a 1 minus v whole to the power half. We can move this half towards the left side and we can write modulus x square is equals to ln. The bracket will remains the same and we can compare both sides, and I can write that my modulus x square is equals to a 1 plus v upon 1 minus v. Now in the starting of this part, it was written as use y is equals to vx. So I can write v as y by x, and when I will substitute this v over here, I can write it as x square. I can remove the mod now. A bracket 1 plus y by x upon 1 minus y by x. This is how I can write. So my x square, if I simplify this further, I can take x as LCM in numerator and denominator, and I will get my answer like this. I can cancel out this. So my x square is equals to a bracket x plus y upon x minus y. Now moving on to the last part of this question, we have to consider this case, and what the question is saying, show that a solution to the original differential equation is this. So for that, we can use the result of the last part, that was x square is equals to a bracket x plus y upon x minus y. We can attempt to clear the denominator and we can cross multiply. I can write it like this. Now let's simplify this further. Ax plus ay. Now we have to attempt to isolate y. So we can write it like x cube minus ax is equals to x square y plus ay. I can take x common, so x square minus a. I can take y common, x square plus a. So from here I can write my y as x square minus a upon x square plus a. And that brings us to the end of question 1. For the complete solution of question 2, head over to part 2 of this video. Don't forget to like, share and subscribe to IB Methodology so you don't miss any part. I'll see you in the next video. Have a great day.